So in this video, we're going to talk about dot products between two vectors. So we'll express a dot product between two vectors. So if we have two Cartesian vectors A and B, and we take the dot product between those two vectors, what this will equal is going to be equal to the magnitude of vector A times the magnitude of vector B times the cosine of the angle between those two vectors A and B. So the reason we use dot products in engineering is the first reason is that we want to determine the angle between any two vectors. So if we have any two vectors A and B and they're drawn in 3 dimensions, we want to determine the angle between them. It's a really simple way to calculate the angle between those two vectors. The second reason we use it is we want to determine what is the parallel component or the perpendicular component of one vector along another vector. So it's really important in engineering to know if you have a force, whether or not it's going along a body or if it's perpendicular to a body. That will often determine whether or not the that body will fail or will be able to withstand that given force. So So for dot products, they follow some simple, all these mathematical laws. So the order that you take the dot product doesn't matter if you multiply vector A by vector B first or vector B by vector A first. It doesn't matter. You can multiply a dot product by a scalar number before you multiply do the dot products together. You'll get the same answer, and then you can take the dot product between two. You can add a vector B plus vector D and then take the dot product with A, or you can take the dot product individually, vector A and vector B, and then add that to vector A and vector D, and you get the same answer. So if you did, so you can take a dot product very easily if you use Cartesian vectors. So what we have here is we have the dot product of A and B, and what we've done is we've taken our vectors A and B and we've written them out in Cartesian form. So we have this line here is just vector A, and this line here is just vector B. Okay, so if we take the dot product of each of the terms, what we end up getting is we just multiply each of the terms out. All right, so we'll get 3 terms for all the products of A of x with bx, by, and bz, and we do the same thing for the second row with A of y, and then the third row with A of z. So if we do that, what we end up getting is we get our scalar values, our A of x, our B of x's, etc. They are put out in front, and then we have the dot product of our unit vectors. Okay, so what we're going to do now is we're going to just look at the dot product between unit vector I and unit vector I. Okay, so from earlier we defined our dot product between any two vectors as being equal to the magnitude of those two vectors times the cosine of the angle between those vectors. So in this case, right, both the magnitude of unit vector I is 1 in both cases, and they're both going along the positive x-axis. So the angle between them, because they're going along the same direction, would be equal to 0, right? And the cosine of a 0-degree angle is also equal to 1. So what we end up getting is I dot I is going to be equal to 1, all right? In a very similar fashion, J dot J and K dot K will also equal 1, all right? So if we look at another point in our all these terms that we've written out here, I dot J, what we end up getting is we get I dot J, the dot product of I dot J is going to be equal to the magnitude of I is equal to 1, the magnitude of unit vector J is equal to 1, and the angle between I and J is going to be equal to 90 degrees. All right, so the cosine of 90 degrees is equal to 0. So the dot product between I and j is going to be equal to 0. All right. So in a very similar fashion, I dot k is going to be equal to j dot I, which is going to be equal to j dot k, which is going to be equal to um, k dot I, which is going to be equal to k dot j. All right. So, and I think I'm missing one somewhere. 1, 2, 3, 4, 5. Yep, that's it. All right, and those are all going to be equal to 0. Okay, so all of these terms are going to be gone, and we're going to be only left with the diagonal terms. All right, so what that ends up being is that the dot product between two Cartesian vectors a and b is just going to be equal to the sum of the products of their x components plus the product of their y components plus the product of their z components. All right. So that is how you can calculate the dot product between any two Cartesian vectors, and we gave the basic definition of a dot product and some of the mathematical laws that apply to dot products.